In this video, we will discuss about maximum beauty of an array after applying operation. You are given a zero-indexed integer array nums and a non-negative integer k. In one operation, you can do the following. Choose an index I that hasn't been chosen before from the range 0 to nums length -1. Replace nums I with any integer from the range nums I minus k, nums I plus k. The beauty of array is the length of the longest subsequence consisting of equal elements. Return the maximum possible beauty of the array nums after applying the operation any number of times. Note that you can apply the operation to each index only once. So what they are saying is that in the input, we are given an integer array nums and we are given a positive integer k. So now what we need to do is, in the nums array, we can take any number and we can replace it with any number in the range that number minus k and that number plus k. Right? So basically, this 4 can be replaced with any number in the range of 4 minus k and 4 plus k. So 4 minus 2 will be 2 and 4 plus 2 will be 6. This 6 can be replaced with any number in the range 4 to 8. 1 can be replaced with any number in the range -1 to 3. Right? 2 can be replaced with any number in the range 0 to 4. Right? Each of the number can be replaced with any number of its corresponding range only once, right? And we can replace any of the numbers, right? Now we need to tell that after these operations, what is the longest subsequence that you are getting out of this nums array where all the elements are equal, right? You need to return the length of that longest subsequence, right? So this 4 can be replaced with any number between 2 to 6. 6 can be replaced with any number from 4 to 8 and so on, right? So if we see here 4, it can remain 4 only because 4 is within this range. 6 can be changed to 4, right? Then 1 cannot be changed to 4. So this we can keep as is. 2 can be changed to 4, right? So these three numbers we were able to change into 4. So this is the longest subsequence that we can get where all the elements are equal and its length is 3. This is going to be our answer in this particular case. This is the longest subsequence that we can get. So see, if you closely look here, since 4 can be converted to a number between 2 and 6, 6 can be converted to a number between 4 and 8 and so on. So whichever is the number that is common in maximum number of these ranges, we can change all of our array elements to that number, right? So if we see, we converted these three elements into 4. If you see, 4 was present within this range, it was present within this range also and within this range also, right? So 4 was the element which was appearing maximum number of times in all these ranges, right? So that is why we were able to convert maximum number of elements to 4 and we were able to get the longest subsequence, right? So now how are we going to solve this problem? So see, if I consider from this array the number 2 and 6, if I consider them 2 and 6, so this 2 can maximum go to 4, right? This 2 can maximum go to 4 and this 6 can smallest go to 4, right? So now this 2 can go to 4, this 6 can come back to 4, then whatever are the numbers that are between 2 and 6, can they also be converted to 4? Yes, right? If we consider this 4, then 4 that is already 4. If let us suppose a 3 was also present here. So for this 3, the range would be 1 to 5. So this 3 would also be converted to 4. 4 is present within this range, right? So what I am saying is that if I have a particular range, and in my range, whichever is the smallest number that can go to 4 and whichever is the maximum number that can also go to 4, then all the elements in between can also be converted into 4, right? So basically, this is my range and in that, this was the minimum element. So if my minimum element plus k is equals to maximum element minus k, then this is one of the valid range where all the elements can be converted into common element or the same element, right? Then if let us suppose I had considered the range 3 to 6, right? So in that case, 3 can maximum go to 5 and 6 can smallest come to 4. Now in this case also, we will be able to convert all of the elements into 4, right? Because 3 can also change to 4, 4 is already 4, 5 can also change to 4. For 5, the range would be 3 to 7. So 5 can also be converted to 4 and 6 is already been converted to 4, right? So can I say that if my minimum plus k is greater than equals to maximum minus k, in that case, the range from minimum to maximum, all the elements can be converted to same element, right? But if, let's suppose here I consider 1. So 1 largest can go to 3, right? Now in this case, this value is 3 and this value is 4, which is less than, right? In this particular case, we can never convert this 1 to 4, or basically all the numbers between this range cannot be converted to a common number, right? So what I need to do is that I need to identify the largest range, right? Or I can say the longest range where this particular condition is being satisfied. Then whatever is the length of that range, that is my answer. But if you see, if I am considering a range over here, so I was considering 2 to 6. So in this particular range, there was a minimum element and there was a maximum element and there were numbers in between. So these are kind of sorted, 2, 3, 4, 5, 6, right? But in my original array, the numbers are not sorted, right? So how can I identify the range? So I am saying, can we sort this array? In the question, we are asked to identify the longest subsequence. Subsequence meaning that we can take any elements from the array while maintaining the relative order, right? While maintaining the relative order of the elements. But if we sort our array, this original array, then we will lose that relative order, right? But if my array is 4, 4, 1, 4, or my array is 1, 4, 4, 4, or something like 4, 4, 1. So in this, if I am considering a subsequence always which is 4, 4, 4, here also 4, 4, 4, and here also 4, 4, 4, since all of my elements in that subsequence are equal, the order actually does not matter here. Right? Because if my ending subsequence is 4, 4, 4, then here it doesn't matter that this 4 came from this 4 or this 6 or this 2. Right? So actually the order does not matter here and we can sort this nums array. Right? So we will sort this, then what we will get? So our array will look like 1, 2, 4, 6, right? Now we need to identify a range. So basically we will be identifying a range that, okay, is this satisfying this condition, or is this satisfying this condition, or is this entire satisfying this condition, right? So since we are trying to identify a range which can be anything, so it is like a sliding window, right? It is like a sliding window which will expand or shrink on the basis of some condition, right? So if in my sliding window, I am introducing an element, and with that element, this condition is being satisfied, then that means that particular element can be included and I can expand my window further. But if introducing a element, this satisfies this condition, meaning min plus k becomes less than max minus k. In that case, I will have to shrink my window, right? And at each point, I can store the length of my current window or the max length that I have got at any point, that I can keep in some variable, and at the end I can return that maximum length as my answer, right? So what we will do is, as we do in a sliding window approach, that we keep two pointers I and j. So initially both of them would be present here, right? Now in this you will apply this formula. So right now this is the window, minimum number is also 1 and maximum number is also 1, right? So 1 plus 2 greater than equals to 1 minus 2. So 3 is greater than equals to minus 1. So that is okay. So we can move our j forward, right? So j will come here now. So now we will do 1 plus 2 greater than equals to 2 minus 2. So 3 greater than equals to 0. So yes, it is. Again, we will move our j pointer forward. So now 1 plus 2 greater than equals to 4 minus 2. So 3 greater than equals to 2. Yes, it is. So we can move our j forward. So now 1 plus 2 greater than equals to 6 minus 2. 3 greater than equals to 4. No, it is not. So now I will have to shrink my window. So I will come here now, right? Now we will again check 2 plus 2 greater than equals to 6 minus 2. So 4 is greater than equals to 4, right? So now we will expand our window. So j will come here. But now we are done with the entire array, and this is the longest valid array that we have got where this condition was being satisfied, right? There was another array where this condition was satisfied, like 1, 2, 4. Here, all of these three could be converted to the number 3. So that is also one of the valid range, and its length was also 3, right? So this is how we can solve this problem. Let's look at the code. So first of all, as I said, we will sort our array. So sort nums dot begin, comma, nums dot end, right? Then we will need a pointer I, right? And we will need an answer variable for storing our answer. Then we will run a for loop of j. So j is the second pointer and it will keep on moving towards the end, right? J less than nums dot size and then j plus plus. Now inside this, we need to shrink our window till our condition does not satisfy, right? So we'll check that while our nums of I plus k is less than nums of j minus k. You do I plus plus. Keep on shrinking the window unless this condition is not satisfied. And once it is satisfied, we will update our answer. So it will be maximum of answer, comma, the length of the current window. So the length of the current window will be given by j minus I plus 1, right? And at the end, we can return our answer. So let's run this. So in this particular case, if you see that we are sorting our array, right? This is the longest or the largest operation that is being performed, right? So in this particular case, our time complexity is order of n log n, right? And if we talk about the space complexity, so we have not used any extra space over here, but in C++, this sort function internally in the worst case takes log n space. So we can say that the space complexity is order of log n, right? So with this, our test cases are accepted. Now there is one more approach of solving this problem, which is a kind of a linear time complexity approach. So let's discuss about that as well. So as I said earlier, 4 can be converted to 2 to 6, 6 can be converted to any number from 4 to 8 and so on. So whichever is the number that is common in all these ranges, or we can say whichever is the number that is appearing the maximum number of times in all these ranges, that is going to be my common element, right? And in how many ranges it is appearing, that is going to be the length of my subsequence, right? So I need to identify that number and I need to identify that in how many ranges is that number appearing, right? So this is kind of a range query problem where I need to identify that one number, right? So now how can we solve that? So we can apply the concept of prefix sum over here. How can we do that? So see, what I'll do is, since in a prefix sum, we need an array, right? We need an array. So we'll create an array. So we can create an array like this, right? Now, this 4 can be replaced with any number from 2 to 6, right? So what I will do is that at this index 2 in my array, I will do a plus 1 and whichever is this number, that is 6. At 6 plus 1, that is 7, I will do a minus 1. Why we are doing this? So see, in a prefix sum, what we do is that in the current index, we add the value of the previous index, right? This is what we do. So if in this particular case, you will see here, if let's suppose it was 0, so here you will get a 1 because of this plus 1. Then you will do 1 here, 1 here, 1 here, 1 here. You will get a minus 1 over here. So from here, you will get 0, 0, 0, 0 and so on, right? So see, for 4, the range was 2 to 6. And here from 2 to 6, we are getting a 1. So it is denoting us that all of these numbers are present in one of the range. And when we will do same thing for all these numbers, then we will get the frequency for all the numbers. For each index, we will be able to identify that in how many ranges is that particular number appearing, right? So now if we do for 6, so for 6 it is 4 and 8. So at index 4, we will do a plus 1, right? And at index 8 plus 1, that is 9, we will do a minus 1. Then for 1, we have a negative 1 over here, right? So see, we will not be going to negative 1 because in our original array, all the elements are positive, right? So whenever any of them would have a range starting from a negative number, we can always boil it down to the 0th index, right? So whenever there is a negative element, whenever there is a negative number, we will boil it down to the 0th index, right? So for this, at the 0th index, we will do a plus 1 and this is 3. So at index 4, we will do a minus 1, right? Then we have 2. At index 0, we will do a plus 1. And at index 4, that is 4 plus 1, that is 5. So at index 5, we will do a minus 1, right? Now, if we try to build our prefix sum, so what it will look like? So this is 2, right? This is 2. This is 0 over here. So this will remain 2 only. Then a plus 1. So this will become 3. Then 3. Now this is plus 1 minus 1, that is 0. So this will remain 3 only. Then we have a minus 1. So it will become 2, 2. again a minus 1, so it will become 1, 1, then this is minus 1, so it will be 0, 0, and so on, right? So now if you see here that which is the maximum element in your prefix sum array, that is 3, right? It is appearing 3 times. Then that means whatever is the longest subsequence that we can get, its length will be 3, right? And in that subsequence, all the elements can be either 2, either 3, or either 4, right? We saw, right, that we could convert all of these 3 elements into 4, right? So there is one more subsequence where we can convert all the elements into 2, right? This 4 can be converted to 2, this one can be converted to 2, and this is already 2. So that is also one of the possible subsequence, right? So this maximum number inside this prefix sum array will get you the answer, right? So now what should be the size of this array, prefix sum array that we are taking? So see, the maximum number in our nums array is 6, right? And this 6 can be changed to 8, right? This 6 can be converted into 8, right? And since for the greater element in our range, we are updating the element plus 1th index, right? We are updating the element plus 1th index, right? So can I say that the size of this array should be the maximum element plus k plus 1, and also since our indexes is 0 based indexing, it should be 2, right? So basically the size of this particular array should be whatever is the maximum value in our array, that plus k plus 2, right? So this should be the size of our prefix sum array, right? So now what will be the time complexity here? It will be somewhere around order of n plus maxi plus k plus 2, right? Somewhere around this, because first we will be running a loop for finding out the maximum value, right, which will take n time. Then we will run another for loop for updating our prefix sum array, which will take another n time, right? And then we will run a loop for this particular array for finding out this answer, right? And the length of this array is maxi plus k plus 2. So that particular loop will run this many times. So the time complexity of that approach will be this. And what will be the space complexity? It will be order of maxi plus k plus 2, right? So let's quickly look at the code. So first of all, let's take the size of the array in n, right? Then we will find out the maximum element. So there is a built-in function present in C++ for finding out the maximum element, which is max element nums dot begin comma nums dot end, right? With this, we can identify the maximum element. Then we will create our prefix sum vector, right? Its size will be maximum element plus k plus 2, right? Initially, all the values will be 0. Then we will iterate inside the nums vector to update our prefix sum. So I less than nums dot size, I plus plus, or since we have already taken the size, we can change it to n, right? Then we will take our start. So start will be nums of I minus k, right? And what will be the end? End will be nums of I plus k, and we are updating the next index, right? So we will do a plus 1 over here, right? Now, if our start in any case becomes less than 0, then in that case, we will update the 0th index and we will do a plus 1 over there. Else, whatever is that index, start, there we will do a plus 1, right? And for the end, we will do a minus 1, right? Now that we have got this, we will take an answer variable for storing our answer. So it will be 0 initially. Then we will run a for loop, I equals to 1, I less than p dot size, I plus plus, and then inside this, we will update our prefix sum. So it will be ith index equals to the previous index or plus equals to the previous index, right? Then we will keep on updating our answer also. So answer will be maximum of answer comma the ith index, right? And at the end, we can return our answer. So let's run this. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.